In this example problem, we're going to look specifically at the relationship between friction and the normal force and how it's used in problem solving. So in this example, we are told that a woman pulls a sled. Why the woman is pulling the sled, I don't know, but it's the example that is actually right from our textbook. And we are told that the sled has a loaded sled has a mass of 75 kilograms. So that means the bathtub and the sled together have 75 kilograms of mass and are being pulled along a surface at constant velocity. Constant velocity is really important. That's language that you should immediately recognize as telling you that there is no acceleration in the x direction. And here I have a note also. The other language you need to look for is that if they tell you it's constant by giving you a specific value, the value itself won't be used. So sometimes you'll see that number there and think, oh, what was I supposed to do with it? It's just constant, telling you the acceleration is 0, so that means in the x direction. If we peek down here, we'll look at where the equation comes from. But since it's constant velocity, the sum of the forces in the x direction will have to be 0. Okay. For any of the problems we're doing in Chapter 6, you want to start off before trying to get an answer by just making a force diagram. So here we have what's called a free body diagram, where we're just going to make the object a single point. So that's this black dot in the center. And all we're going to do is identify all of the forces that are in the problem. I will normally put gravity in first because gravity acts straight down. mg, I don't write it in as F sub g or W, I just go right to mg, 75 kilograms times 9.8 meters per second squared, so we have a 735 Newton force pushing down. We have to be careful not to just lapse into saying, oh, then the normal force will also be 735 newtons, because in this case, we are going to see that this tension force, the tension in the string, or the rope, in this case, pulling up at an angle of 42 degrees, as given in the problem, is going to contribute an upward force of T sine 42, helping to alleviate some of the 735 newtons from the floor. Now, in the x direction, we have T cosine 42, or T cosine phi, and friction is fun. So friction is always mu times the force normal, and here we were given the coefficient of friction is 0.1, so we know the coefficient of friction. And then if we know the force normal, then of course we know the frictional force. Well, let's separate our page into an x direction and a y direction and sum the forces in each of those directions. And again, for this chapter, that will pretty much always be a recurring theme in the mode that we're going to use to problem solve these problems. It really doesn't matter in terms of writing down the equations which way you start, but write them both down before starting to solve the problem numerically. So here I've started with the y direction, and sum of the forces in the y direction equals mass times acceleration in the y direction, and because we have no movement up or down, right? The sled isn't sinking into the floor and it's not lifting up off of the floor. Acceleration in the y direction is 0, and notice I just account for all of the forces. I don't worry about really thinking through all of the details of it. I simply write down the forces that are there. So we have the force normal up, we have T sine 42 degrees in this case up, and we have gravity mg down, and that has to equal 0. So I'm going to box that equation. And in the x direction, we only have two forces, T cosine 42 minus the frictional force, mu times the force normal. And now I'm going to plug in my numbers. So notice how much analysis was done prior to going right to what many people would think of as the solution. You will find solving the problems, especially the harder ones, are much easier for you if you'll do this upfront analysis with your free body diagram, sum the forces in the x and y direction. Now try to really solve the problem with the numbers that are given in the problem. The other nice thing about doing it this way is we kind of see we have some confidence that it is solved by counting equations and unknowns. So in the y direction, we have force normal. T sine 42 minus 735 equals 0. And in the x direction, we get t cosine 42 minus 0.1, because we were given the coefficient of friction is 0.1 times the force normal equals 0. And really now we know the problem is solved. We have two equations and two unknowns. We are simply going to solve for one of the variables. In this case, I solved for the force normal in terms of the tension, plugged that back in over here to the force normal, and then I had the tension all by itself, solved for the tension, subbed the tension back in over here, and got the force normal. So in terms of your best approach to consistently solving these problems following the procedure of a force diagram, write the equations out, then plug the numbers in, get your number of equations and numbers of unknown into the problem, and at that point, the only points you would lose would be possibly -1 for an algebraic mistake. So there you have it. We're going to continue to do more of these. Some of them will be a little harder than others, but hopefully you are now prepared to start solving these types of problems on your own.